Okay. Mr. Hunt here, I'm going to go through angles in triangles and some theorems that we do with those. The first thing is just knowing the types of triangles. Just study page 1. You probably know a lot of this stuff. What an acute triangle is, how to name a triangle, that a triangle has 3 sides and 3 angles, like in here. Do use the symbol like this for triangle, and name 3 points for a triangle. So read through those. Every triangle has, you can classify by its sides or its angles. So you can classify it 2 ways. By its angles are these 3. And all triangles have at least 2 acute angles, so the third angle really decides what it is. This one apparently might be new, equiangular. Equal angles. All the angles in the triangle are congruent. And if it's equiangular, it's also equilateral. And if it's equilateral, it's also equiangular. We'll learn that later, but I can also let you know about that right now. And then, so by its sides are these 3. Scalene, no congruent sides, isosceles 2, and equilateral all 3. Isosceles, though, is at least 2. So actually an equilateral triangle is a type of isosceles triangle because it has 3, but it includes that it has 2. The state says know this now. Know how to put this in a chart, in a hierarchy, so you can see how to classify triangles. They're a type of polygon, and then you can classify it by its sides or angles. Here's the 2 I mentioned, 0 congruent sides, 2 congruent sides. Equilateral has 3, so it's underneath isosceles. Let's see what else. So then by its angles, you got acute, less than 90, right, exactly 90, and obtuse, one angle bigger than 90. Acute, all are less than 90. Equiangular is a type of acute. Equiangular has 3 60-degree angles, and so it's a type of acute. I'm going to move on, but feel free to pause the video and go back. I want to do 2 main theorems. The angle sum theorem is the name of the theorem that the sum of the angles in a triangle is 180. A fact you probably know. So the first thing we're going to do is look at the diagram here. We have a triangle ABC. We have 2 lines that are parallel. Okay. And we're going to show that 1 plus 2 plus 3, the sum of the angles in a triangle, is 180. I'm first going to say that measure 1 plus 4 plus 5 equals 180. Because any number of angles that make a straight line are going to be what the straight line is, 180 degrees. We used to do linear pair. I call this linear trio. What I'm actually doing here is I made what could be about 4 steps into 1. There's a lot of technical stuff we could have done with taking the angles and making them, adding forward 1 to get, and then 1, 5, and putting them together. I'm just saying 3 angles, they come together, they make a line, it's 180. The other thing we know is because lines are parallel, this is what we did last unit. If I go like this and draw that in, do you see how alternate interior angles are formed with 4 and 2? So angle 2 is congruent to angle 4, and at the same time, along a difference transversal, excuse me, angle 3 is congruent to angle 5. So that's just the alternate interior angles here. Okay, as long as lines are parallel, if they're not parallel, you couldn't say it, but if they're parallel, alternate interior angles are congruent. You say that's the theorem. Alright, last 2 steps, we just change these 2 equations and plug it in. So measure angle 2 equals measure angle 4, and measure angle 3 equals measure angle 5. So I changed those to an equation. This would be definition of congruent angles. And then what I can do, is plug each of those in to this equation here. So I'll keep a measure of angle 1 but I'll put in measure angle 2 for 4, and I'll put in measure angle 3 for 5. And that was just substitution. Okay. Again, pause it if you need it. I'm going to move on and talk about exterior angles. I don't know, I guess I can tell you about a third angle theorem at the top of the page there. So right under angle sum theorem. The third angle theorem, I'm not going to prove it, but here's what it says. I have one pair of angles congruent in these two triangles, even though they're different sizes. It could be the same size. There's a second pair, the 91 degree angles. I have two pairs of angles congruent in the triangles. The third angle theorem simply says this. If two angles are congruent in the triangles, between the triangles, the third angles are congruent. We can conclude those angles would be congruent as well. And we're very clever, we call it the third angle theorem. If two angles of a triangle are congruent to two angles in a second triangle, the third angles are also congruent. Okay, and then I want to talk about the exterior angle theorem. The exterior angle is an angle on the outside of a triangle. And now you have to form it so by extending one side of the triangle. Then that creates an angle. If you don't extend one side, there's not really an angle that you can really make. Let's see. So it's an angle formed by one side of a triangle and the extension of another side. And so it's angle 1 there. Now angles 2, 3, and 4 are all interior angles. But 2 and 3 are called remote interior angles because they are remote from 1. They are far away. They are secluded from angle 1. Right, it's always in reference to an exterior angle. So if I had actually done a different exterior angle, now this one, 4 and 3 would be the remote interior. Let's see. So then the interior angles of a triangle are not adjacent. This is the actual definition. So we can't include 4 as a remote interior angle because it's adjacent to 1. Based off of this, the exterior angle at the bottom theorem at the bottom says that the measure of angle 1 is equal to the sum of 2 plus 3. So it's equal to the sum of the measures of the two remote interior. The exterior angle is equal to the sum of the remote interior. Here's a simple example why. If this one's 100, angle 1, there's a straight line making angle 4 80. Then this triangle is 180. And so if I subtract off the angle I used, I'm left with 100 between 2 and 3. So there we go. It's the same as this one. So we don't know if it's 90 and 10, 50 and 50, 99 degrees and 1 degree. We don't know what they are, but we know that they must, 2 and 3 must sum to be this one. All right, it's important to prove this one, so I'm going to prove it. Write statements and reasons. Let's see, this is good. I'm going to quickly jump in here. Okay, so two conclusions from the diagram. All we have is the triangle, and then we can figure out how 2 plus 3 is equal to 1. All right, now the exterior angle 1 is equal to the sum of 2 plus 3. Okay, so 1 and 4 are supplementary. Supplementary angles. 1 and 4 are supplementary. This is, you can write definition of linear pair or just given. It's given in the diagram. 1 and 4, hey, they're a straight line, so they're going to be supplementary. Excuse me. And from that, then we can say measure of angle 1 plus measure of angle 4 equals 180. That is just vocab word, supplementary definition of supplementary angles. What else do I want here? Okay, so that's one thing, and then the next thing I can do, I need something else. I can say these, there we go. The theorem we just used. We know the sum of the angles in a triangle is 180. So measure of angle 2 plus measure of angle 3 plus measure of angle 4 equals 180. say in words, the sum of the angles in a triangle is 180. Or you could say the name of the theorem, it's angle sum theorem. It's now unit 1 proof, because line 3 and line 4 on the statement, they're each equal to 180. And what we've done for a while is when they're equal to the same thing, we set them equal to themselves. So we set these 1 and 4 equal to 2, 3, and 4. I'm going to put 2, 3, and 4 first because up here I need 2 and 3 on the left. Okay, but if we didn't, if you put this one first in line 3, it would have been symmetric property. You would have had to add in at the end. So measure of angle 2 plus measure of angle 3 plus measure of angle 4 equals up here measure of angle 1 plus measure of angle 4. Substitution or transitive, you could have put it. And finally, you just need to subtract off the 4s. So we have measure of angle 2 plus measure of angle 3 equals measure of angle 1. Subtraction. Okay. That's the exterior angle theorem. And then to finish up, I want to talk about corollaries and 2 quick algebra problems. A corollary is literally a mini theorem, a little theorem. It's a statement that can be easily proven using a theorem. You could also just basically call these theorems or more properties that are true. Usually they're easier to prove, and so somebody decided we're going to call them corollaries. The first one is going to be proven in the practice. If you have a right triangle, the acute angles, these two, all right, are complementary. Right? Again, it's kind of like that one we were just doing, like the extra angle one. Well, I don't know what they are exactly. It could be 80 and 10, 45 and 45. Don't know exactly, but I do know that their sum is going to be 90 because there's already 90 here, and a triangle is 180. So we got 90 left. Another one, there can be at most one right or one obtuse angle in a triangle. Can't be 2 or more. We'll actually prove that later in the unit. And then to finish up, find the missing angle. Well, we're just going to find x up here. You can apply some of the theorems we just did. The first one, I see a triangle, and they're all the 3 angles of a triangle. Therefore, we can sum them. X plus 74 equal to 180. We're going to combine like terms, and we get, oh, that's a plus. X plus 183. You also could have just, the first step, if you already added them, you could have done that. And then we subtract 183 and get -3. And as long as you don't get, like when I plug that in, I get 71 degrees. That's fine, as long as you don't get a negative angle. So you can have a negative x as long as you don't get a negative angle. And then B, okay, these are not the 3 angles in the triangle, so I can't sum to 180. But this is an exterior angle, and these are the 2 remote ones. So the exterior angle equals the sum of the 2 remote interior angles. So I'm going to combine like terms on the right side of the equation to get 82. 89 minus 7. Then, subtracting 5x will have 9x. And subtracting 1 will get 81. And then dividing by 9.